Good day, I am Sadev from Achievers Academy, and today we will be looking at complex numbers. This will be a playlist, and please make sure to go through all the videos in the playlist so you can have an idea of the full topic, complex numbers. Now, at the end of the playlist, this is what you are meant to know. We are to take on the issue of complex numbers very briefly. We'll look at the definition of complex numbers. We'll look at the real part and imaginary part of Z. We'll look at basic operations of complex numbers, addition, subtraction, multiplication, and division. We'll be looking at powers of I. We'll be finding the modulus and amplitude of complex numbers. We'll take a look at the Argand diagram, which is a graphical representation of complex numbers. We're taking looks at the forms complex numbers can appear in. And a form which it can appear in is polar form. We'd also be looking at finding the argument, principal argument, and conjugates. We'll be looking at the Moivre's theorem, which was brought forth by a French man. We'll be taking a look at the nth roots of complex numbers and roots of unity. So at the end of this playlist, this is all you need to know in order to pass or sit for any exam. So let's begin right away. Number one, history of complex numbers. So I'll put a simple example here. We don't have to go to complex for this. Let's given an equation. The equation is x minus 1 is equal to 0. X squared minus 1 is equal to 0. And if we were to solve this, they say look for the values of x, right? So what do we have? We would have x squared. We take minus 1 to the other side, giving you plus 1 is equal to 1. What do we do next? We square root both sides. So we take the square root here, we take the square root here. The power here cancels the square root, and we are left with x is equal to the square root of 1. Now, what is the square root of 1? The square root of 1 is simply plus or minus 1. I'll shed more info on this later, but x is equal to plus or minus 1. Now, if we move further, I give another example. Let's take this example. X squared plus 1 is equal to 0. Now, notice the change in sign. Here is a minus, here is a plus. So let us begin to solve this. So what do we have? We are going to have x squared is equal to minus 1. Now, what do we have next? We square root both sides. So the square root of x squared is equal to the square root of minus 1. Square root cancels this. We have x is equal to the square root of minus 1. Now, what is the answer to this? There is no real answer. Why? Because for square roots, you need two numbers that when you multiply together gives you that value. What I mean by that is, if you are given the square root of 4, that means you are looking for two different values, say 2 and 2, that when you multiply gives you 4. You are looking at the square root of 9, you are looking at two values, the same number, mind you, that gives you this value here. So whenever you're dealing with the square root of minus 1, there are no two numbers that will give you minus 1. You can try 1 and 1. 1 and 1 gives you 1, not minus 1. You can try minus 1 and 1. That doesn't give you 1. It gives you, they are not the same value. You can try minus 1 and 1. Minus 1 and 1 are not the same value, even though it gives you minus 1. You can try minus 1 and minus 1. It gives you plus 1, which is not the value here. After now, we get to find something interesting. We find that taking the square root of any negative number, say minus 9, it also does not give us the two values, same values like this, to give us this value here. So this is where we introduce complex numbers. All right, that is where we introduce complex numbers. Now, this is the definition of a complex number. A complex number takes a simple form a plus bi. Now, a plus bi, you need to note that this is the real part and this part is the imaginary part. And whenever we write complex numbers like this, the real and imaginary part, we put a z in front. So z here denotes complex numbers. When you say z, it denotes a complex numbers. Now, let us go and see how we can solve this kind of equation. Now, if you are given this kind of problem to solve and you got stuck at x is equal to square root of -1, this is where we come in and say anything square root of -1 is equal to I. Yes, we literally call it I. I meaning imaginary number. So imaginary number, it's not on the real plane. When I mean real plane, I mean from 0, 1, 2, 3, -1, -2, 1, 2, 3, 4, -1, -2, and so on and so forth. It's not existing on that plane. We literally made up a new number, or I will even call it a number. It's more of a letter, but it functions as a number here. So we just call it I. So that's one thing you need to note. The I is called imaginary number, and I is equal to square root of -1. So you need to box it up somewhere. This is your I, and this is the foundation and basis of whatever we'll be doing here in complex number. I is equal to the square root of -1. Now, when I say the complex number denoted by z is equal to a plus bi, what I simply mean by that is it contains a real part a and an imaginary part b. So let me give you examples of complex numbers. If I say z is equal to 4 plus 3i, this is a complex number. A complex number consists of a real part and an imaginary part. A real part and an imaginary part. Now, how do you know which part is real? How do you know which part is imaginary? You simply look at where your I is positioned. Where your I is means it is an imaginary number. So 3i, this is the imaginary part of the complex number z. Another thing you need to take note of is even if you are not seeing, for example, 4 and they give you z, z means there's still a presence of an imaginary number, but it can just be something like 0i. Even if you are not given, you are given something like 3i, it can still be written as 0, which is the real part, plus 3i. So it doesn't matter how they write it. So far, you're dealing with complex numbers and you're just seeing a value 4. It just means plus 0i. And z, if you're just giving 3i, it also means 0 plus 3i. Now, there's one thing you need to note in this part of complex number is that they don't add up, right? They don't add up. So I said a plus bi. So z is equal to a plus bi. If you're given questions to solve on that and they say add 3 plus 3i, ladies and gentlemen, you can't add these two up. This is an imaginary part. This is a real part. They can't take part together in any kind of basic operation. But there's something we can use. We can add, we can subtract, all those basic operations. We can still perform them, but not in the same way. We'll take a look at how we can perform these basic operations. Now let's move over. There's still a lot to talk about on history and definitions of complex numbers. So now I said there's a real and imaginary part. So the real part, real, you can also write it as, remember I said z is equal to what? Complex number. And a complex number consists of a real part, and b, an imaginary part, I. So your real part here can also be written as your real of z. That means the real part of a complex number z. Your imaginary part IMA can be written as your imaginary of z. So this is how we would denote it whenever else we are going forward. So let us take some basic operations of complex number, and in the next video we will look at other outlines that I've given out. So let us take some basic operations of complex number. So this is a subheading. So like I said earlier, you can't add a real part and an imaginary part. You can only add a real to a real and an imaginary to an imaginary. You can only add or subtract a real to a real or an imaginary to an imaginary. So let us take addition. Addition of complex numbers. So question 1, and please write this down. If the complex number z1, it can be denoted anyway. If the complex number z1 is equal to 3 plus 2i, and another complex number, you can call it anything. Let's just call it z2. It doesn't matter whether they give you 1 and 2. It just means these are two separate complex numbers. And they say z2 is equal to 4 plus 3i. It will tell you add okay, let's see, what is z1 plus z2? Now, here is the solution to that. So, a real to a real, imaginary to an imaginary. So, we know that z1 is equal to 3 plus 2i, and we know that z2 is also equal to 4 plus 3i from the questions. So, we can only add the real part. So, the real part in this equation is what? It's 3 and 4. So you can only add 3 and 4, the real part. So what's 3 and 4 added together? Let's call this final equation. You can call it Z3, or let's just write the answer. So this is our final answer. Our final answer will just be 3 plus 4, which is 7. And then you can only add the imaginary to an imaginary. So 2i plus 3i. You don't need to add up the i's here. You just say plus 2 plus 3, 5i. So this is the addition of this. All right, only add the real to the real and an imaginary to an imaginary. Add up 10 plus 5i, and z2 would be 13 plus 4i. What will be the answer? The answer to this will be 10 plus 5 and what? 5i, and then 13 plus 4i. You can write it anyway. So if I should just write z1 plus z2, you are simply saying 10 plus 5i plus 13 plus 4i. This will just be equal to, if we remove the bracket, it's still the same, 10 plus 5i plus 13 plus 4i. Add up the real to the real. 10 plus 13, 23, plus 5 plus 4, 9i. This is your final answer. Let's take one more example, and then I give works to try out. Let us take this example. If z1 is equal to 4i, and then z2 is equal to 14 plus 7i, what is z1 plus z2? Now, if you are confused, remember what I said, that even if you're just given 4i, it just means there's a presence of still a real part, since it is the imaginary part that is missing. The real part will just be 0 plus 4i. So we are just adding 0 plus 4i to 14 plus 7i, and this would be 0 plus 14. Okay, let's clear out the brackets first. So the brackets will just simply be like this, clearing out the brackets, and then this will be equal to 0 plus 14, which is still 14, and then 4i plus 7i, which is simply 11i. So that is that on additions of complex number. Let's say they give you z1 is equal to 10 plus 3i, and they say z2 is equal to 7 plus 2. Find z1 minus z2. What is the answer? Now let's put it out. Z1 minus z2. 10 minus 10 plus 3i, and then minus, now the operation is minus 7 plus 2i. So like I said, you need to first clear the bracket. Unlike addition, where everything just goes, now you need to multiply. You see this minus, it get fed in here and also affect this here, right? So you don't just write it out like that. This will be 10 plus 3i, minus times 7 would be negative 7, minus times positive 2i would be negative 2i. Now you have it arranged. Still the same thing. You take your real to real, you take your imaginary to imaginary. So you can still polish it and say 10, and then I'm collecting like terms, minus 7, then the real part now plus 3i, the other imaginary part minus 2i. See, if we finish this up, this will be 10 minus 7, 3. 3i minus 2i will just be what? Positive I. So you can either say plus 1i or simply say 3 plus I. This is the final answer. Let's take another example here. So if we're given z1 to be 7 minus 2i, and then we are given z2 to be 3i minus 3i plus 4. Here's a mistake you might make. Don't just rush into solving the problem. You might need to polish it up a bit. Remember they said z1 minus z2. Now what is z1? z1 is simply 7 minus 2i. And z2 is what? Remember the operation here is negative. Minus what? Minus what? Actually, let's not do it like that. Remember, in a complex number, it is a plus bi. So the real part should come before the imaginary part. Here, real comes before imaginary. Imaginary comes before real. So you can still leave it the same way. It would be the same operation. But really, what you just need to do is just to flip them. So the real part to come first, which is 4. The imaginary part goes second, minus 3i. We continue. This would be clearing out the bracket, 7 minus 2i. Minus here gets fed in here to give us negative 4. And then same minus sign gets fed to negative 3i. So minus negative 3i takes us to what? Positive 3i. So this will be plus 3i. Let's proceed. We clear it up like I said, and we all now know the real goes to the real, the imaginary goes to the imaginary. So here will simply be 7, the next real part, minus 4, next real part, negative 2i, sorry, imaginary part, next imaginary part, positive 3i. This clears out to be 7 minus 4, 3, and negative 2 plus 3i gives us just I. So even though they have the same answer, there's no real correlation. I just actually just give this out now. So this will be the final answer to this problem. Now we have seen the addition and subtraction of complex numbers. Though in the next lesson, we will take a look at the multiplication and division of complex numbers. So we are successfully able to check out the history, do a brief definition. A complex number contains a real part and an imaginary part. We talked about the real and imaginary of z. We saw some basic operations. And for now, that will be the end of today's lecture. And in the next video, we'll take a look at powers of I and the rest. But before we leave, let me just show something. Let me show the forms of a complex number. So please pause this video and write it down. So these are the forms of a complex number. You don't need to be worried too much. We would cover everything. Now, if you notice, we've only been looking at this form right here, which is what your Cartesian form, which is fine. This is like the simplest form it will come in. Your Cartesian as having a plus bi. An example is me saying 3 plus 2i. This is your Cartesian. This is your a, and this is your b. Now, we would see other forms of complex number in later videos. But basically, all we've been doing now is adding, subtracting, and performing basic operations of complex number in rectangular form, or you can call it Cartesian form. So thank you for reaching the end of today's class, and see you all in the next one. Thank you.